The next problem we are going to solve this, that is a problem that is analysis of plate with notches as shown figure. Analyze the plate with FA software. Okay, and then the property of the material are given. The Young's modulus 210 GP and Poisson's ratio, that is mu is equal to zero point 0.3. Here we require another parameter, that is for geometry of the plate, it is thickness of plate, that is equal to T equal to 10 mm. So this is the geometry of the plate which is fixed at one end. This radius arc R5, total height is 40, width is 100. This circle is situated at 50 x direction and 20 y direction of radius 7.5. So first we just create a geometry. So just as this procedure, go to Analysys multiphysics, then preprocessor, go to modeling, create key points, then inactive CS. So first key point is at the 0 region 00. So either put or leave as it is. Apply. Second key point is at 20. So 20. Apply. Third key point is at that third key point we have to create it is this one. So that is it is 25x and minus 5. So 25x and y is minus 5. So okay, so these three key points are created, it is 1, 2 and 3. Now what we have to do, instead of creating all these key points, we just take a reference of these three key points and copy it. So for this, just go to copy key points. Now suppose I have to copy this key point 3, that means this key point 3 at this position. So this distance is 50 because this 5 and this 5 gets minus from 60. So 60 minus 10 becomes 50. So this key point number 3 is transferred to the 50 direction, 50x direction. So the key point is selected, apply, and here it is x distance, y distance and z distance. So we have to give the x coordinate, that is x offset, so which is equal to 50. So okay, so now 3 is copied to 4. Then next again copy this 2 to the 60, that is this 2 second key point is copied to the 60. So that is copy key points 2, apply, and the distance is here now 60. Okay, so this key point is created. Again we have to copy this 4 key point to the 20, that is this key point to the 20. So that is again select copy key points, this key point, apply, which is distance is 20. So okay, now next we have to copy the same key point in a downward direction of depth, that is height is 40. So all these key point is transferred to the 40 distance. So select copy key points. So this one, second, fifth and sixth are transferred to the 40 distance, that is these key points, this one, this one, this one and this one to the 40, it is this location. So we selected key points, apply, and here it is x is 0 and only y is minus 40. So okay, now key points are get copied. Then again 3 and 4 we have to copy at this location, that is here. This 3 is copy here and this 4 is get copied here. So copy 3 and 4, apply, that is the distance is now minus 30. minus 30. So key points are get copied. Now we have to create a circle. For circle we have to mark one key point over here. Okay, so just go to create areas, circle, solid circle. So first for that solid circle, suppose we define WPX and WPY. Instead of doing this, just create a key point here and select that key point as a center. So cancel it. Okay, so I just created here one key point. So go to create inactive CS. Then what are the number that is after 12, which is 13. Here it is 12 last. So we define the 13 key point. So X is 50 and Y is minus 20. Here it is X is 50 and Y in minus 20 because XY is here, so that Y is minus 20. Apply. So key point is created. Okay, now create a circle. Now create area circle, solid circle from this, and the radius is equal to radius is 7.5. Okay, so this is created. Now next we have to create the area at outside position. So create area by lines. So first create line, then lines, straight line from this to this, this to this, this to this, and here it is. Here there is arc is present, so we have to create an arc. So okay, now create arc. Now again to create arc there is a one method. So create lines arc, choose by end key points and radius. So when this first dialog box is open, then we have to choose two endpoints. That is, suppose here if we have to create it here, so this one and this one. Apply. Now we have to define the center position. Now if you refer the figure, the center for this arc is over here. Again center for this arc is over at this side. Center for this arc is at bottom side, and again center for this arc is at bottom side. So we have to give a center. So we choose these two key points, and center is in this side. So choose any one of the key point which lie on upside in this direction. Suppose we choose 5. Apply. Now define the radius which is given 5. Okay, now this arc is created. So similar way in this position by end key points. So select the key point through which we have to create arc. So this one and this one. Apply. So the center is in this direction. So suppose you select this key point, whatever you choose, you can select also this one and this one also, but it should be in upside. So apply. Again radius remains same. Okay. Again we have to create at the bottom side arc. So same position, same method. Then select this starting, apply. Then the center for this is in this direction, it is over here. Select any one of the key points. Suppose we select this, apply. Radius remains same, apply. Again this one, apply. Center is over, suppose here, apply. Radius remains same. Okay, so this is our complete geometry. Now we have to create the area by using these lines. So go to create areas, arbitrary by lines. So pick all lines. Okay, now area is created. Now go to plot, multiplot. Now what we have to do, here is a circular pocket, that is like this. So we have to subtract this area. So go to create, go to modeling, operate, booleans, subtract areas. So select the area from which we have to delete this area. So this is the base area. Apply. Now which area we have to delete it, that is subtracted, this one is middle one. So okay, now the complete geometry is created. Fit. Now again this is only plane. If you see in a isometric view, it acts as a only x and y direction, that is plane of paper. We have to provide a thickness also. So again go to front view, provide a thickness. So for thickness we have to first define a element type. So for this type of plate problem we have to take element type, add element, add solid, that is plane 183. So select this node, this plane, this element. Okay, and here it is. For that we have to define a thickness. So just after selecting element, go to option and change here plane strokes with thickness. So that is okay. Close. Now define real constant in terms of thickness, which is given equal to 10. So add edit, add for this element. Okay, and here it is 10. Okay, close. Now just define perform meshing. Before that define the material properties, material models, structural, linear, elastic, isotropic. Then the material property are given 210 gigapascal and Poisson's ratio is 0.3. So 210 into e raised to 3 and the Poisson's ratio is 0.3. Okay, close this. Okay, now the modeling part and preprocessor part is over. Now we have to perform meshing. It is in meshing. Now this area is critical area. Okay, so first go to we have to perform the size control. So size control, manual size, areas, peak areas. So this area is peak. Apply element edge length. Suppose we define element edge length is equal to 2. So okay, then next go to mesh. After that mesh we have to perform meshing of this. So go to area. Now as this is a critical one, go to free, this one. Okay, now meshing is performed. If you see the meshing is very fine. Okay, now save db. Then next apply load. Either you apply load from this side or in solution the define loads is also applicable. So whatever you prefer, it's depend on you. Load, define loads, apply structural displacement. Now if you refer the problem, this total side is fixed and we apply pressure on this direction. So just select apply the load, that is displacement should be 0 at this side. So for that, as we know, we apply the displacement and force on node point. So first go to plot and plot node point. So node points are selected. So just move in this direction and perform zoom. Now again displacement on nodes. Now if you observe these totals, this side nodes are should be fixed. So to select these nodes, pick box, draw one box. So nodes are selected, which is count equal to 41. Apply the all degree of freedom should be 0. Okay, so nodes are get fixed. Fit. Now for this side. So again zoom, move this side. Okay, now we have to apply a pressure. We apply pressure mostly on a line. Okay, now again go to plot lines. So these lines are selected because we have to apply pressure on line. So load, define loads, apply structural pressure on lines. So line is selected, apply. Now if we define the minus 60, that means the pressure is applicable away from the body, which is given in our problem. It is away from the body. And if we define positive 60 here, then pressure is towards the body, that is in this direction. But we have to apply the away from body, so we put here it is minus 60. Okay, close. Okay, so this is the direction of pressure. Now go to plot, multiplot. All loads and the displacement are applicable. Now go to solution, solve, current ls. Okay, solution is done. Then post processor part, general post processor, plot result, deform shape, deform plus and deform. Okay, so this is a deform shape. Plot control, capture image, we have to take a printout of this image. So file is save as, save this file is in your folder. Close this. Now next, counterplot, nodal solution, counterplot, nodal solution, DOF solution, displacement vector sum. Okay, so this is the displacement 0.40.0468 at this, which is red zone. Then next, plot control, capture image, we have to take a save this file because we have to take printout. Then next, list result, nodal solution, DOF solution, displacement vector sum. So that is this displacement in a table format. So okay, so these are the displacement. Okay, again file save as in your folder. Close this. Then again the reaction solution, all items. Okay, this is the reaction solution node wise. Okay, close this. Then we have to take a element table data, but for element table data, so element table data we do not consider for a plate problem. So this is the complete solution of our plate analysis of this problem.